Hi, long time since last time I've uploaded the video. This one will be something different. It will be about electronic loads. So what you see here are electronic loads that I've bought through eBay, and it's quite a impressive load in terms of power dissipation. That is, if I remember correct, it's up to 60 watts, and you can control the current and the voltage limit, meaning you have a function to move from a general load in order to discharge a battery for a specific voltage, and then it will stop. And this is quite impressive since the price is pretty low for such a load. And let's check the accuracy of the current that we are using. I will use a Regal power supply, which have a very good accuracy in measuring the current, and I will compare to this current electronic current load. And first I will explain how this is actually working. So I've looked at these boards, and what we can see is that we have a controller beneath this board with the LCD, and actually what it is doing, it is putting a load. So how the load can be accurate. So let's talk about the accuracy of the load. So I don't see any resistor here, so this is not done through a series resistor. It is done in a different way, and I will explain how I see it. I'm pretty sure that I'm right. Okay, so basically, if you need to do an accurate load, so it's like putting a resistor. For example, if you have a 1 volt and you want to do a discharge of 1 amp, so you need to use 1 ohm resistor. And here you don't have a changeable resistor, because there are no such a thing for very high current. Anyway, I'm not familiar with such devices. And the concept here is that we are using a MOSFET. Okay, so I will put it here. So sorry about the focusing. So this is the power MOSFET that should manage all the power dissipation, and the load, since I don't see it here, so probably my estimation is that the load is this wire. This is the load. Interesting, but this is the load. In order to dissipation all the power, so we have internal resistance of the MOSFET, and we have the resistance of the PCB and the resistance of this interconnect, which is just a wire. So what they are doing here, my guess is that are estimating that all the series resistance is, for example, I don't know, maybe something like 50 milliohms. And if you know that it is 50 milliohms, so you can calculate everything pretty simple, meaning you don't have a reading current sense here. This is not such an accurate. It is just converting PWM, and by the PWM and the resistance that it, let's say, it has to estimate a resistance, a specific resistance. And if I can estimate the resistance, let's do an example. It will be more maybe understandable. So the example is like this. If I have let's say 100 million resistance. Okay, so if I will use it for discharging 1 volt, so the current will be 1 volt divided by 100 million, which is 0.1, so I will have 10 amps of discharging. So if I know that I have 10 amp of charging, if the MOSFET is conductive all the time, so if I will apply a PWM of 50% like this, and it will be a 50%, meaning half of the time is on and half of the time is off, and I'm working on 1 volt, so the discharge will be 5 amp. And if the voltage for this 50% will be 2 volt input, so I will get back to 10 amps. Meaning, depending on the voltage that we are reading and on the resistance that we have measured, and generally this is the basic resistance that need to be accurate, more or less, so I can convert everything to current. But since I don't see any feedback, I'm not sure, I think I don't have any feedback to read the real current, like a Hall sensor effect or something else, so I guess the accuracy of this device can't be very accurate. Okay, so this is an assumption. In order to confirm my assumption, I will use 2 devices that are the same. I will apply a voltage and I will put it into a current, and I will compare the current that I see here to the current that I'm measuring in my regular power supply, and this will give me the answer if this load is accurate or not. So let's begin with the measurement. So I will later put on the camera the regular power supply in order to compare, or maybe I will change now the angle of the camera, so you will be able to see the current flow in this device and the current in the regular, and we will see how accurate it is. So let's start. And another one thing, the accuracy in low current and in high current can be with a variation depending on the heat of the MOSFET, and the heat can change some parameter on the PCB and change the resistance from drain to source. So let's do it. I will change now the angle, and we will see what we have. Okay, so now we can see regular power supply, the electronic load. By the way, the electronic load need 12 volts in order to operate the component itself. We have here the current source, and let's move to a mode. Now it is. We have the regular power supply. I will put it on I don't know, something. Let's put it on 5 volts, 3 amps, which means that it can output up to 3 amps. We have here a polarity, so let's put the polarity in the correct manner and power it on. Now it is not doing anything because I have to press the run button, so I will press the run button and we have error 3. Why is error 3? Probably because of a limitation of the voltage, so I will apply a higher voltage in the regular power supply, 6 volts, and I will run it again. Okay, so now we can see that it is running, and the current here, hope you can see, I will try maybe to zoom a little. The current here is 1.4 amps and the actual current on the Regal is only 1.3 amps. This is good. This is good. We can of course calculate the error and see that it is pretty good. Now I will move to 2 amps. So I will stop it and I can move between the functions and move it to 2 amps and I will run it again. So we can see that the current on the Regal is 1.87 and the current on the device is exactly 2 amps. Now what we will do in order to see the accuracy, so remember 2, let's write it down, 2 amp here and 1.86 on the Regal. Now I will move to the other device and try to compare between the results. So I will stop it. I stopped the Regal power supply. I will change the device to the second one, and of course I have to change my load, so I will do it online, so we will see that I'm not bluffing anyone. Okay, so let's take it out. Disconnected, and we'll connect to this one. Okay, and the other tab. So I will now apply same setting, of course. So I will move to 2 amps here. Just a second. And here, how do, okay. You can move like this to be more accurate and not run, and just a second. And here I will down to 6 volts. Now I want accuracy of 2 amp and 6 volts. Now I will run this device. First I will power again the Regal. Now we can see that we have 2 amp here and 1.76. Okay, so before we have 1.86, meaning as expected the real measurement of the serial resistor is something that they measured once and they realized that it should be something and they have an error. So this is a little about the electronic load.